good morning, all. So I am happy to see you all of you again on Sunday morning at 10 sharp. So thanks for overwhelming response for the past week, and I believe we will be able to continue the same momentum for the upcoming days as well. So I am expecting you to give it in a chat box that my volume is clear, my screen is perfect. So if I'm loud and clear, you just please let me know so that I can go ahead and start the session. In the meantime, I will close all the unnecessary apps which disturbs us. Yeah, I have ETAP, I have Digsilent Powerfactory, OBS anyway, which need to run. Teams I may need. So all other things I will close it. Yeah, fine. So I'm expecting you a feedback whether my screen is visible or not, and I am loud and clear. If I'm right, probably I can start. I am looking for few comments from your end. If it is perfect, I can go ahead. Yes, I think it's clear. Yeah, thank you. Thanks for your confirmation. Let's go ahead. And if you have any questions, please post it. Right, perfect. So yes, everyone is giving screen and audio is fine. Yep, thank you. So let's discuss a few questions from the last week which we have not really answered it, and we will go ahead. But meantime, if whatever the questions which you have, you can really post the questions and we can discuss, right? So means let's take a question. I think we have answered a few questions, I believe, but I felt means something which we can add. I got an opportunity of go through in the first session only. There is a question from Shasi. I'm not sure whether he has joined it or not. And you can also, I mean, what to say, uh, post yourself like you're a student or an industry so that I can easily understand your background. Yes. And Sasi's question is, I mean, so to say, ask regarding OLTC selection. And my first question is simulated no load state of transformer which results of no loss. So he's basically asking about means in a no load condition where is a no load loss. I believe I have added last week a little introduction about it, but let me go and probably talk a bit more on this. So to ensure I am starting the project with IEC standard and 50 Hertz. Yes. So if you take a transformer, I believe the screen is further visible. I'm just enlarging it. Yeah, thanks Sasi for confirming that you have joined. Yeah. So the impedance. So if you look at this transformer ETAP modeling, this ETAP modeling means what to say, it takes only the load loss into account for a load flow analysis, and only for an unbalanced load flow, it takes the no load loss. Say example, I believe, let me quickly go to an example. I will try to simulate this in both the simulation software ETAP and Digsilent Powerfactory and how the results changes. So if I have an 110 bar 11 kV transformer, yeah, I'm just giving 25 MVA transformer with a typical impedance, right? I'm just trying to focus only the no load loss. I'm trying to focus only the no load loss. Yeah, transformer is now without any loads, so it's there is no losses here. If you want to display this branch loss, it is 0 kilowatt and 0 kVR, and let's show the units as well. So the losses is 0, right? Perfect. So even if I give losses, no load loss and parameters, if I give, say example, I am giving the no load current as 0.5% of the full load current, and loss for this 25 MVA transformer, say example, I am giving, say example, 10 kilowatt, just for an information. Let's look at whether this is captured here. Answer is again loss is 0 kilowatt. Simple reason, because the software ETAP in a balanced load flow doesn't account this no load loss. Irrespective of whatever the data which you give, balanced load flow, what we are running now, means how to say that this is a balanced load flow. It is by default understood in ETAP that it is a balanced load flow. So if you ask that, so here means what to say, balanced load flow, it will not account the no load loss at all. If you want to account the no load loss, what's the analysis which you need to perform is, you need to perform unbalanced load flow. You need to perform an unbalanced load flow. Unfortunately, I think as I told last week, we don't have that unbalanced load flow model, so we may not be able to simulate and showcase you. But means what say, if you have an unbalanced load flow, you can very well perform. If you perform unbalanced load flow, then you will get the losses here, like 10 kilowatt or whatever the losses which you have given. And of course, this losses you have to enter basically based on the data which is from the uh, FAT, factory acceptance test, or the manufacturer guaranteed value before the FAT. So I think that's clear. Yes. So the same scenario which I will try to simulate it in Digsilent Powerfactory. Let me take a new project itself. So here, yeah, I'm taking a 110 bar 11 kV bus. This is 11 kV. So I'm connecting a grid and a transformer, a two-winding transformer. So obviously this transformer rating should be 110 bar 11 kV. So I'm taking a, yeah, 25 MVA. I'm giving same data, 110 bar 11 kV, maybe 10 percentage impedance, and typical impedance value is what I have given. So if I just want to match apple to apple with the ETAP results, I can give an X by R ratio of 20. But probably means what to say, Digsilent allows me the opportunity to talk about, I mean, give this parameter in 4 different ways, whereas ETAP gives only one option. Like in ETAP, if you look at, you can give percentage Z and X by R. That's the only way of you can give the data. But Digsilent, I mean, what to say, if you have the percentage impedance and the copper loss, you can directly feed that right now, like 124 kilowatt which is there in the measured data or something, you can directly enter. So Digsilent gives about 4 options, but ETAP doesn't offers anything. And if you want to really know a little more on how to enter this X by R, means we have a video in our channel, X by R itself. Yes. So means there is a video which is available, which you can really watch here in the transformer X by R ratio. We have compared the CTAP and Digsilent Powerfactory, how to enter the parameters, everything. That's an interesting video which you can really watch, right? Okay, now I have done with that, right? So zero sequence impedance also which I have given. Load flow I'm coming. Load flow here there is an option like no load current, 0.5 kilowatt. I'm trying to match the same data here with 10 kilowatt what I have given it in ETAP, and I have to give a grid to run the load flow analysis. Yes. So 110 kV grid and 110 bar 11 kV transformer. So the same data what I have modeled in ETAP, I'm plotting the same data here. You can run a load flow analysis. Sorry, I have clicked short circuit. You can run a load flow. This load flow you have options like balanced, unbalanced, everything. I'm just running a balanced. Right. Here you can see some data which is appearing, which means means what to say. You can really plot those results with units, and you can give means number of decimals as well. Yeah, so I can probably give a text box adapt with. Yes, so what is the loss which I have given? Loss is appearing here. That means Digsilent Powerfactory is accounting this no load loss even in a balanced load flow. It is really right approach. But ETAP not really accounting this no load loss in a load flow analysis. That's not strictly right, but there is no load loss is a very small quantity, so that can be neglected. That will be the error, or that's an error which you are tolerating when you are performing a load flow analysis in ETAP. Yes, I think before going far, let me take up some questions. There is a question from Vishal Kumar. How do the transformer energization study? Yes, you can do transformer energization study in Digsilent Powerfactory using EMT model, and you can probably ETAP claims that they can perform transformer energization study in means in ETAP also, but that's not accurate. It is better to always go with the simulation softwares like PS CAD or EMTPRV to perform transformer energization study. using EMTP model, that is transient stability. There is an option in EMT model that you can use it in Digsilent Powerfactory, and you can perform transformatization. So that's a big study. Again, I believe you have an option. Means we already had a video in our YouTube channel. The video what we need to refer you is like one of the video which we have talked about, the transformatization study. Bhupati has talked from, yeah, here it is, installation coordination using EMTPRV. There he has touched this transformatization study using EMTPRV. So that you can watch, Vishal Kumar. And if you want, means dedicative class, that is probably a bit lengthy class, we go ahead, means what say, we will come up with means later phase, right? Jeevan is asking, is this a new class or it's a continuation of last week lectures? It's not a new class or it's not a continuation of lectures. Generally means the questions what the audience are putting in the all my live sessions, I am unable to answer it. That's the real reason why we had this class on every Sunday morning 10 o'clock. I will come and I will address all the questions which you are posting it. So today means whatever may the questions in the chat box I will take, and also what are the questions which has been asked in the last week AskSelva, that also I will take up that question. So that's how it goes. Yes. And probably I think if that is clear, let me come to this question. I believe I have answered this. Yes, no load loss is accounted in load flow analysis in Digsilent Powerfactory in both balanced and unbalanced load flow. ETAP accounts that only in the unbalanced load flow. Right. So how to calculate manually the positive and negative sequence resistance of the transmission line? I think this we have answered it last week. I have not really taken all the questions from the last week. Means if you have any questions, probably means if you want me to address today this class, I'm happy to address it. You can post your questions in the chat box. I will take up that question. So probably if you are relate with respect to means what to say, mostly confined to means if you look at the description we have given, like load flow analysis is a topic today. Anything and everything related to the load flow you can ask. We will answer this. So like so that we are not jumping from different studies. I mean, first few weeks we'll have a load flow, and first next few weeks we'll have a short circuit and something like that. Yes, done. So how to calculate this manually positive and negative sequence resistance? There are quite a lot of textbooks which are available, and I believe I mean what to say, last week also I have explained this little bit of how to find out this parameters, line parameters in ETAP. But how to do that in manually you can very well means what to say, refer some textbooks. But even if you refer textbooks, if the number of circuits are more with more number of earth wires, then doing it manually becomes difficult because the size of the matrix will be bigger. So if I am taking a 400 kV network, let me talk two questions with respect to the simulation. So one, this is what he has asked: when I have given this parameters, automatically software calculates the line resistance and reactance when I have given the phase conductor, ground wire, and of course this configurations of the conductor. I have assumed means horizontal conductor with a single ground wire. If I have given the data of height, spacing between the conductors, spacing between the phase wire and ground wire, and of course the phase conductor details and the earth wire details, automatically the software calculates the impedance. How to do this manually? There are quite a lot of textbooks, basic power system books, which helps you to answer this question, how to find out this. Yes. So let's move on to the next question. Yeah, how to model shunt reactor and series capacitor. So shunt reactor, I think we have explained last week. There is no direct shunt reactor which is available in ETAP. So you have to model it as a lump load with zero power factor. So that consumes reactive power. Even that should be, you have to model with a constant impedance load because the reactor is a constant impedance. Or you can take up a static load and you can model with a zero power factor. So that's how you have to model it. Yes, and but there is another question which he has asked, the series capacitor. Last week we have answered that question with way like you can model this like you have an option called impedance. In the impedance you can give a negative x value, like if I'm putting it in ohms, like you can give -40 or something. Then this XL is basically series reactance. If I give negative value, then that is a series capacitor. So you can model this series capacitor in ETAP by means of using this impedance tab and giving the negative x value. That's one way of doing it. There is also a straightforward way of modeling it, like here you can have an option called compensation, that is from the latest versions. So here you have an option like fixed series compensation. What's the 400 kV, what's the MVR, what's the amperes, what's the XC value. You here itself you can directly give this values. Like if you have taken this 300 kilometer, total line length is 300 kilometer. If you look at the impedance is I mean, so to say, I have given some data. So here impedance is too high, that is 0.6, but in reality it's in the range of 0.4. Okay, so that means the parameters what we have given here is not really right. Okay, here and here, that's what the meaning of it. Okay, so if you have means get this reactance value into length 300 kilometers, sorry, that is per mile. That's the reason why it is appearing 0.6. That's right, sorry for that confusion. Yes, the x values will be approximately means 0.4 ohm per kilometer. Previously it was in miles. That's the reason why it is showing about 0.67 or something. Now it is right. I mean 300 kilometer line reactance is 0.37 ohms per kilometer. So approximately 300 into 0.37, which you can put. So let's assume we are going to compensate this line with the fixed series compensation, and degree of compensation value is 50%. That means 50% of the line reactance which we are going to model. So 300 is the line length, 300 kilometer, and line reactance value is 0.37554. So this is the length, this is the reactance value in ohms per kilometer. So total ohm, if you want to find out for the entire length, yes, this is the total ohms for the entire length. And if you want to compensate for the 50 percentage, degree of compensation is 50 percentage, then you need to give 56.331 ohms as a XC value, which is going to be connected in series. How to do that? You can add here directly, that is XC, so you need not even give negative, so 56.331. So which you can really model, right? Right. Okay. Fine. So you can compensate from end, or you can compensate from two end. All these things are possible, right? And you can put MOV protections, that's possible, and bypass which is open or closed. All these things which you can take. If bypass which is closed, then fixed series compensation is bypassed. If bypass which is open, then your series compensation will be in picture. So now let's assume there is without fixed series compensation. Let's assume some 400 kV 300 kilometer line. Let's try to plot the results. Let's try to plot the results, right? What's the loss which we are getting in the line which look at? So let me slightly reduce the zoom so that you can understand these parameters. Yes, let me plot the results in megawatt so that it will be easy. Yes, so here you can see line length is about 300 kilometer. The loss is approximately about 1.6 megawatt, and reactive power is 257 MVR. That I think because I have given 300 miles. Yeah, if I give 300 kilometers, yeah, the loss is about 0.322 megawatt, and the reactive power injected is about 152 MVR, and receiving end voltage goes to about 105.5 percentage. Receiving end voltage goes up to 105.5 percentage. If you put a load, of say example 300 megawatt, if you put a 300 megawatt load, even at say example 95 power factor, yeah, say like 300 megawatt with say 100 MVR, about 95 power factor. If we are running a load flow for this case, you can say the receiving end voltage fall down to 93.47 in both the cases, which is not acceptable. What I mean by that, During loading conditions, the voltage goes to under voltage, and during the no load conditions, the voltage goes to over voltage. In both the cases, the receiving end voltage is not acceptable. So if I go with the compensation, I'm adding some compensation. Let's look at what the compensation does. So compensation, I think bypass which I have to look at. Yeah, this is open. MVR, probably you can find out the current and you can enter the MVR. Say assume that current carrying capacity of that 400 kV line is 1000. Yep. It can have 168 MVR. This is a fixed series compensation. Bypass switch is open, so it should impact positively, but unfortunately it is not doing. So let's validate the same thing with the series reactance with the negative value. How to do that? I mean, so you have to give this XC value as negative, like minus 40. You can do the compensation at sending end or receiving end at the middle. You can talk quite a lot of it. And when you say, means what's the middle or 2 by 3rd distance is an ideal distance technically, but in a reality that's not really advisable. Simple reason because of the it needs an additional substation at the center or at 2 by 3rd distance. So generally you connect this fixed series compensation at any one of these stations. So now I have approximately compensated the same value, right? Previously I have given some 56.63 or something, it came right. Compensation, sorry, that value I think I can look at from Excel. Yeah, 56.331 is the value which I have to give it in ohms, minus which I need to give minus 56.631. If I am giving that, let's look at what's the impact. So if you look at means what to say, this impact of this with respect to this receiving end voltage, and just a minute, you need to look at whether percentage you have given or ohms you have given. That is most important. You have to give, this is balanced and percentage 56.63. so this has to offset 50 percentage of the length. It has to offset the 56 percentage of the length. And let's look at, let me check whether operating, no, perfect. Yeah, so this has to reduce the real and reactive power losses in the transmission line. Simple reason, because I mean we are compensating this line reactance. We are compensating, I believe this results are visible. This compensation, I mean this reactance, line reactance, we are compensating by this shunt capacitance, sorry, series capacitance. So which mean, let me quickly go into the small exercise like how this transmission line is modeled. Yes, I think this is visible. If you have the long transmission line, this line reactance has a crucial role to play that limits the power transfer capability, that increases the voltage drop, etc. So even power transfer capability, you might be aware that P equal to EV by X into sine delta formulas. So this line length increases, the line reactance increases, that reduce the power transfer capability. In order to compensate this line reactance, we are adding a series capacitance. That could be either fixed series compensation or that could be a thyristor control series compensation. You don't have option to play with thyristor control series compensation, but at least you can model this fixed series compensation here by means of adding this negative value in the reactor, in the impedance, or you have an option to compensate that using an option compensation, right? Fine. So before going for, let me take a few questions from the chat box. Okay, Vishal Kumar, what is the impactance of the minimum short circuit current? Okay, so means today we are talking about load flow, but still I will quickly answer your question. The minimum short circuit current is mandatory for your motor starting studies, that is needed for your transient stability, that is also needed for your harmonic analysis, That is also needed in case of protections which you want to validate whether your relays are able to pick up for the minimum fault current. So that's all the reasons why do we need minimum short circuit current. There is a question from Kanagraj. Approximately specify the resistance load data range, how to consider the power factor and other things. Kanagraj, you can directly get the data from by means of measuring from the residential. So generally the power factor will be in the range of about zero point 0.8. So means what is the load data etc. means you can really means what say do the actual measurements, or probably means many people might be doing some auditings etc. for household applications nowadays, that's growing. And means I will connect you offline to give you the data if you want, means if you want to use it for this means I believe that's for a research purpose. Yeah, that data which we can give. Parthiban, yes, my system having only generator, no grid connection. Which mode generator to be operated? Swing or voltage control or KVR control or power factor control? It cannot operate in KVR control and or power factor control. So to simulate your case, so let me switch off Parthiban. I mean this both the generators. Let me take a small example of. Yeah, I have gone for this. Uh, Hope you know this option, check circuit continuity, which enables or disables the equipments which are live. So assume that I have only one generator which is operating and it is feeding all the loads in the industry. Then what mode which you need to keep? You have, I mean, so let me model the transformer itself. Maybe 11 bar 415 which I take. Assume that the generator is available at 11 kV and many loads are connected. Yeah, I will take up one by one questions. All the questions we will take it up. Yeah, so let me take some small 2.5 MVA transformer. Yep. So I think I have already told this. Typical impedance when you give it in ETAP, you have to double check with IEC 60076 latest version. The software is giving the data, typical data from the old standards. That's not really right. So if you have generator, whether to operate in what modes, I think that's the question from Parthiban. I assume that, say example, I have 5 megawatt generator which is operating at whatever may be the mode. Means let's put Qmax and Qmin value. I think many other videos we have talked about how to enter this Qmax Qmin value. So I am just quickly giving the data. So I kept this generator on. I have kept this generator in the voltage control mode. Now this is enabled, probably right. You can see enabled in the sense it says that circuit continuity is on, but it will be on only when you have an option which you have enabled in ETAP projects, that you can treat the voltage control source as a swing bus. If you make this as a false, then probably your PV bus will not be taken as a swing bus and hence it will be also automatically disabled. That means you need to ideally operate it in a swing mode, but you can keep it in a voltage control mode. You can use this option also, like that option enables or that internally converts the PV buses into the swing buses, that is voltage control source as a swing source. That's the option which is possible, right? And I can keep it in a swing bus. That is an ideal way of doing it. If you keep it in MVR control mode or power factor control mode, automatically your system will not have any voltage regulating device in your systems. At least we need one device which is able to regulate regulate the voltage and frequency in the system. So anyway, I mean, we are not really accounting the frequency in load flow because we assume that swing bus takes whatever may be the mismatch, but at least there is another bus which has to regulate the voltage, right? So that means swing bus is mandatory. So if you are giving voltage control mode, if you enable that option which I have shown in tools option, then automatically it will take as a swing bus and it runs. You cannot operate your generator in MVR control mode or power factor control mode. Okay, let's have to talk about this in two ways, Parthiban. One is what is a simulation, second one is what is in a real time. So in a real time means what to say, voltage control mode is something different, where you are fixing real power and voltage. But when you are having only one generator and you are feeding the loads without connection to the grid, you cannot operate in that real power control mode. You cannot fix P, because you need to adjust your real power generation to match the demand each and every moment. So that is called isochronous mode. So you need to operate your generators in an isochronous mode when you are running this generators in the islanded systems. That means that's the only generator, then you have to operate your generator in isochronous mode, right? Yeah, I think in a transient stability you have an option to choose your data as like a droop mode or isochronous mode. Okay, so I means if you have only one generator, then you have to operate that in isochronous mode. That's about real-time systems, but I think how to model it in ETAP, I have talked about this. I believe that's clear, Parthiban. Yeah, if you have further questions, you can really post that in the chat box. I will take it up. Yeah, what is the difference between KVR control and power factor control? That's a good question. KVR control and power factor control remains the same in ETAP, right? It's almost like this. But means there is a difference between MVR control and power factor control. If you are putting it in MVR control, irrespective of change in the real power, the reactive power Q is maintained constant. That means, example, 500 megawatt generator. If you are putting the generator in MVR control mode, and if you are fixing this Q value is 200, because of the grid frequency changes, or because of the governor operations droop, or whatever may be the reasons, if the real power changes, this reactive power remains 200. There is no change in it. But if the same generator, if I am putting it in power factor control mode, then means when the real power changes, the reactive power also changes. When the real power changes, the reactive power also changes. So let's have some small example to prove that. That will be interesting. So let me go back to my first system, right? Let's take the same example, 110 bar 11 kV. Assume that this 11 kV we have a generator, and let's enable the grid. Let's simulate this. Let's try to give some correct data of this generators. Let me rotate the generator. So generator capacity, let me take say 25 megawatt at 0.8 power factor, right? So here I am mentioning it is 25 megawatt. How to find out this reactive power? That you know, what is the lagging side power factor? So that is 18.75 MVR. I have assumed 0.8 power factor lag, and taking 95 power factor lead, it is minus 8.217 reactive power. This is the reactive power which it can generate. Yes. So now means let operate this generator in a power factor control mode itself. So if I am putting the generator in power factor control mode, and if I am putting the power factor as 95, then it generates 8.217 MVR. Right? It is generating 8.217 MVR. If if I am changing the power factor, the reactive power changes. The beauty is, I am retaining my power factor. I am retaining my power factor at 95. I am changing the real power generation. I am changing it from 25 megawatt to 20 megawatt. So you can see the generated capacity is 25 megawatt, but that doesn't mean it has to generate 25 megawatt. It can generate 20 megawatt also. So when it is generating only 20 megawatt, the reactive power generation previously was something else. Now it has came down. So this is the power factor control mode. That means for the power factor remains constant. So when real power changes, the reactive power also changes. That's the power factor correction. But if you put it in MVR control mode, here you can see I am keeping it 20 megawatt 6.574. That is corresponds to 0.95 power factor for 20 megawatt. Let me run. You will get the same results. It is generating 6.57. And if I am increasing power back to say example 25 megawatt, if I'm increasing back to 25 megawatt, still the MVR remains same, only the power factor is changing, right? So hope you got the point. So MVR control mode keeps the MVR, the reactive power, constant, whereas the power factor control mode keeps the power factor constant. That means whenever there is a change in the real power, the reactive power generation changes. Hope that answers your question, Parthiban. You can probably put it in the chat box if that is answered. I think that's all the questions. The session is Q&A, so you can post your questions. But I personally expect the question to be means what to say, uh, related with the load flow. If that is related to the load flow, I'm happy to take. If the question is for a short circuit or motor starting or relay coordination or a transient stability, yes, I will be happy to take it. But we have planned this session continuously from every Monday, sorry, every Sunday at 10 a.m. So we can very well discuss that in the days to come, right? Yeah, I am sure I have not missed any other question. I believe I have answered all the questions. Yes, I think yes, I have answered all the questions of today's session. So I will take up the few questions from the last week. So for that, let me go back to this question, which is a snapshot which I have taken from the last week Q&A, right? Yeah. There's a question from Srinath. I think he might be joined or he might be available. So do all the simulation softwares when it comes to the load flow, whether it is unbalanced or balanced or unbalanced, because real-time system is always balanced. Yes, real-time system is always unbalanced. So means what to say, you necessarily need unbalanced load flow. But means what to say, if you go with an unbalanced load flow, the time consumption, the modeling, the memory, everything goes up. So means if you are able to means what to say, spend that much time, money, effort, everything, then you can definitely have to go with the unbalanced load flow. That's obviously right. But sometimes means what to say, because of this unbalance in 400 kV systems or 220 kV systems are too small, that means the unbalance is quite less. You can very well assume that this unbalanced system is a balanced system. That's what we are considering, and we are doing a balanced load flow. But it is always recommended to go for an unbalanced load flow, which gives much accurate results close to the practical systems than means converting or assuming the unbalanced system into a balanced system. Hope that answered the question of Srinath. Yes, we need to do unbalanced power system as an unbalanced load flow only, but unfortunately due to time constraints or modeling constraints or the effort which we need, etc., I mean we are not really modeling it as an unbalanced load flow. Most of the times we convince ourselves with a balanced load flow. But if you go with the single phase systems, or if you go with some tractions where you have a heavy unbalance, absolutely it is mandatory you have to do the unbalanced load flow. Yes, there is a question from Mohan Kumar. Do we have any Indian standard for a load flow analysis? No, there is no specific Indian standard for load flow analysis, Mohan. Yeah, let me go ahead with other questions. But if you have any other questions, probably you can put it in the chat box. I'll take up that questions also. Yes, there is a question from Sois. In load flow results, the load bus will have a negative voltage angle. Even the infinite bus is modeled as at a positive zero. So hope many of you got his question. What he's asking? He's asking in load flow results, the load bus will have a negative voltage angle. Even the infinite bus is modeled at positive. So let me take up that example in ETAP itself. For that, let me switch off this and let me take this. Yeah, let me delete this. Let me directly connect this transmission line with the network. Let me bring it in service. Yes, his question is I need to plot the results with an angle. His question is why this is negative. Why it is negative? That's what his precise question. Sorry. In load flow results, the load bus will have a negative voltage angles. Even the infinite bus is modeled at positive zero. I have modeled this infinite bus with an angle 0. So if it is a load bus, obviously means what to say, this will be with a negative angle. Means in some of the previous classes we have discussed the power flow, real power flow will be always from higher angle to lower angle. And here is a swing bus, and if you are connecting a load here, the power has to flow in this direction, then obviously this angle has to be less than this. Since you have given 0 here, automatically this will be less than that, then obviously it has to go to negative. If you assume, say, the slack bus angle is 30 degree, then 30 degree minus 12.62 degree will come at this place. That will be positive, which you can claim. But in the reality, what we need to really look into is the reference, with respect to the reference angle, what is the angle difference? That's what you need to look at, not the absolute values. That means when I have changed the angle of the swing bus from 0 degree to 30 degree, this bus angle becomes 17.38. But it is not really meaningful if we say 17.38 or 0 or minus 12.6. We need to always talk about the angle difference between this and this, that is del 1 minus del 2, or always when you are talking about del, you have to talk about this relative angle only, not the absolute angle, because absolute angle will change when you change the angle of slack bus or swing bus. Yes, I think there is a question from Sasikumara. If I have multiple grids, how to model it in software? As my all angles will be referred on a slack bus angle. If I have multiple slack, which angle it will consider? So means what to say, if you have multiple buses, you have you can consider like, let me take this, let me delete this load and I'll connect the grid also, then that becomes obviously a multiple slack bus. Yep. Yes, so if I means we'll say here also I have assumed it's right. So here I have I mean, so what to say, because of the angle difference, the power is flowing, which you can understand. So here I have given 30 degree, here I have given 0 degree, so the power flow is about 720 megawatt. If I make angle 0, then there will not be any power flow. So if you are modeling multiple slack bus, then you need to understand means why it is multiple slack bus. That is to answer Sasikmar. If you have modeled your system with a multiple slack bus because the state is connected with many other states, and that bus is to be referred as a slack bus, then means you need to give an appropriate voltage and angle in order to match the real and reactive power flow. So yes, I mean the software allows you to model multiple slack buses. For all the slack buses, you can give voltage and angle. So if you take all the bus voltage is 100% or 1 per unit and angle is 0, that is may not solve your purpose. That will not match the power flow in each and every branches of your particular state. So means then you need to ask a question, why do you need to model this multiple slack bus or multiple grids? So it is not advisable to connect two different sources within your industry. That means, example, if you have an industry which receives the power supply at say 110 kV, if you are getting means power supply from ABC place 110 kV, and if you are getting some other 110 kV from XYZ, it is not allowed or it is not advisable to parallel this two sources which you have received. One is from the location called ABC and the other one is called XYZ. That's not really advisable. Simple reason, because let me probably also simulate and tell why it is. Like, say example, if you have a grid of say ABC, it's 110 kV, and I am just connecting a say a transmission line, and assume that this is an industry. Assume that this is the industry substation, and this is 110 kV. And if you have given the line parameters, maybe I have to keep it every time is in kilometer. Okay, without parameters, let me go and take some assumed parameters. Just to save the time, I'm doing this. Okay, and if I have another source, if I have another source, right, this is industry bus, sorry for the spelling mistake. Yes, so if this is coming from grid A, say example ABC, that's from some location, and if this is coming from say example XYZ, that's a different location. Shall I parallel this two different grids? Shall I parallel this two different grids at my industry substation? There is two different yes, is it possible to connect it? This two here? We may think yes, it is possible, but that results in means or say huge uncontrolled power flow via your industry bus. So let me run a load flow. Right here, the power flow is now very small. Right, it is 100 angle 0, and this 0.027 MVR is because of this line length of 1 kilometer. Right, perfect. So if it is a 10 kilometer, then the reactive power will be slightly more. And now you can see there is a reactive power already started flowing across your in your branch, right? Yes, so here you can see there is a power flow, and there is a power flow which is here, that is 0.122 MVR, which is flowing in your industry substation even if you have not connected any loads. And this uncontrolled power flow will be much different when any one of this substation voltage is slightly different. Say example, if I am taking one substation voltage is 1 or 2 percentage, then you can see there is a huge reactive power which is flowing via your industry substation, right? You can see about 21 megawatt and 84 MVR is flowing via your industry substation, though I have not connected any loads in my industry. That means in an industry you might be having further 110 bar 11 kV step down transformers, and you might be feeding the loads here. But what you have done for your industry, for a reliability purpose, you have taken two different supplies and you have paralleled it at your substation. If one substation from where you are receiving a power supply voltage is 1 or 2 percentage and other one is 100 percentage, there will be a huge uncontrolled power flow which will be flowing in the um, your via your industry substation, which is not really allowed. So mean, if you are an industry, you cannot really connect two different sources at your premises. You are not allowed, you are not authorized, and if you do that, then there will be an uncontrolled power flow. This uncontrolled power flow is just not because of the voltage, it could be for an angle also. Say example, if I am keeping back again 100 angle 0, the power flow will be almost negligible, 0 megawatt. But assume that if that angle is more, say example if the angle is 5, that's huge power. Yeah, you can see there is an enormous power which is flowing via your industry substation. Your bus bar of that industry substation may not be capable of handling this much current, right? If you plot it in current, yeah, around 2000 amps current will flow via your industry bus, which is not feeding your industry loads. Your industry loads will be means here 110 bar 11 kV, and you will be feeding these loads, and you may not have sized this bus bar, industry bus bar, to means capable of carrying this power flow along this transmission, this substation. So your industry substation is basically designed to meet the loads of the industry, that is like maybe 25 MV or 50 MV, the current will be quite less. But if you connect two different sources here, there will be an uncontrolled power flow through your industry bus. That's because of the just not the voltage mismatch, but also the angle mismatch. And whenever there is an angle mismatch, the power flow will be uncontrolled, real power flow will be there. And if there's a voltage mismatch, there is an uncontrolled reactive power flow will be there. And of course real and reactive power depends on one another, on each other. So whenever there is a means real power flow, automatically there will be a reactive power flow as well. Yes, hope that is clear. That's to answer a question for Sasi Kumar. You should not connect multiple grids at your industry if you have something like this. But when you have a state and if you're modeling the state, uh, and probably means for say if the state has interconnection with many other states with multiple points, then the question is whether to model that as a grid, that is a multiple swing bus or not. Answer: you can look at what is the real-time scenario, what is the power flow between these transmission lines, and you can put up a load with that power flow as a connection point rather than having multiple grids. Or else if you have decided to go with the multiple grids, then you have to select the right phase angle and voltage magnitude so that the power flow is means what say matching with the real-time scenario. Hope that is clear, Sasikumar. And there is a question from Parthiban: two or three generators is operating in parallel. Again, no grid with my system. In this case, how to select the generators mode, swing or other two in voltage control? That is a tough question, Parthiban. I think last week we have touched that. Means if you have three generators operating in parallel and if you are feeding the loads, if you select one generator as a swing bus and if you keep other two buses as a PV bus, then they will be means what say start means what say injecting some constant power, and even sometimes your swing bus will power will be in reverse. That's not really right method. That's what last week also we have discussed a little bit on the capability of the softwares. When it comes to the islanded systems, swing bus concept is not really an ideal way. So you need to look at the primary control or a secondary control or the load sharing based on the inertia or something like that. So in that case, probably Digsilent Powerfactory is more powerful. So I will take this question in detail in the next week, so that probably I can come up with some simulations. I will model say maybe two or three generators. I will be keep changing the loads, and I mean, so see, we can simulate such results in both ETAP and Digsilent Powerfactory. And Digsilent Powerfactory a little bit which I have talked about. So definitely I will come up with some simulations next week to demonstrate the capabilities of the software. So means if you look at the active power control, I mean, so to say as dispatch, that is with respect to the reference machine, but you have another options like I mean, so to say according to secondary control, according to primary control, according to inertia. There are many other possibilities which are available in ETAP. That means these concepts are not based on the swing bus, and that will reflect more closely with respect to the real-time systems. So yes, probably since you are from an oil and gas sector, means for when you are simulating for a multiple different load flow configurations with generators, more than one generators operating in an islanded systems, I mean, you need to ensure that real and reactive power generated by all these generators are same. But unfortunately, when you are simulating it in ETAP, that will not be same. That's a drawback of slack bus concept. That's not a drawback of ETAP software. Means if you use a slack bus concept, this is a problem which you need to face. So you need to really, you need to really means go with some other concepts like here. Secondary controller, primary controller, according to inertia, you have to have different algorithms, right? If somebody has not understood Parthiban's question, let me quickly simulate a small case. Yes, let me at least show the problem what means what say Parthiban is trying to explain, and probably next week I will come up with some simulation examples in both ETAP and Digsilent Powerfactory and see the results. Yes. So let's say the generator rating is 5 megawatt at 11 kV, and it is 5 megawatt 4 MVA and minus 2. This I am just simply putting it. You need to put right answers there. Just for the time sake, I'm just means doing it. So this is let's take a small cable also. Let's model a different length cable as well. So hope you know the option like copy and paste and copy and move from dumpster, right? There is an option like copy paste and copy move from dumpster, right? So let's take a let me take a complicated case itself first. right? Let's take this line length is not line, it's a cable. So let's take 50 meter as the cable length. 50 meter is a cable length. Yeah, 185 square mm cable. So let me copy this. I am putting the load, a lump load here. I need to model the industry detail downstream, but I'm just lumping everything and I'm putting it like 15 megawatt, so maybe 5 MVR, right? Perfect. So I'm just running load flow to check the results. So if you look at this, here intentionally I have made the results right. So let me probably move this also aside so that the results will be visible. Yep, I believe the results are visible better. Yes. Now what I have done, I have put all this generators are in a voltage control mode and I am running a load flow. So means what I have given 15 megawatt 5 MVR. I have given the length of the cables as equal, right? Let me display the cable lengths. I have given 50 meter each and I have given the loads as same as means what say equally sharing by all the three generators, like losses is almost nil. So means what say each generator is generating 5 megawatt and to meet this demand of 15 megawatt. If we have means what to say, if the 15 megawatt load is reduced to say 12 megawatt, what we expect? Yeah, let me put that question. Let me put that question. So my question is like, assume that the cable length is same, and if the load reduces from 15 megawatt to 12 megawatt, what's the expected power generations from the individual generators? That's my question. You just answer that question in the chat box, then we will discuss more. So 15 megawatt is the demand now. So all the generators are generating 5 megawatt each. If I am reducing this 15 megawatt to 12 megawatt, what's the expected power output from each generators? That's a question. I am expecting the answers in the chat box. Yeah. Meantime, if I have any questions, I will take up that question. There is a question from Vishal Kumar. When a substation receives a two sources, then it is the same case as two grid sources with a tie bus. Then how we are controlling kilowatt and kVAR power flows? Vishal Kumar, I think probably you might have confused with the previous example what I have given. Yeah, to showcase, I will switch on the circuit continuity. If I have a double circuit from the same common bus, that means if bus 8 and bus 9 is not two different bus, if bus 8 and bus 9 is the same bus, that means this is not substation ABC, and if this is not substation XYZ, then means it's a double circuit line which you can parallel. But this is coming from some other place, and if this is coming from some other place, then you have to, I mean, sort of say, design the system will be, means what to say, it is a bit difficult. Yep. Means you should not parallel two different substations at your industry bus. If this is a common, means this is not coming from a two different substation. If it is the same station and if you have a double circuit line, that's fine. You can parallel it. I believe that is clear, Vishal. Yeah, Naresh, there is a question. 400 kV double circuit. How to calculate the actual value ohm per kilometer? Yeah, actual value ohm per kilometer. I think one of the Excel sheet which we have narrates on the transmission line parameters. I'm again sorry for taking you back to our YouTube video, but means we have answered all these questions. You just go to this transmission line modeling. Okay, we have referred one of the Excel sheets. Okay, that consists of all means what say 110 220 kV. 400 kV from 11 kV to 400 kV, all the transmission line parameters that Excel has. I believe you will be able to find out the link of that Excel sheet in this video in the transmission line modeling description. Yes, I got only two answers. I think 4 megawatt each. Okay, from each generator. Yeah, generation will be remain same. I think I got only two answers. Let me wait for a few more answers. Yep. Yeah, Naresh, you tried manual calculations. not coming as a correct value. And Naresh, we can discuss this offline, and I'm happy to help you because means unless otherwise, what is your assumption? We cannot really we cannot really look at that. Yes, Naresh. So if you're asking the link of our channel of that particular video, then I have to means what to say. You can follow our YouTube channel, but anyway, I will give you this link. Yes, just give me a second. I will share that link. But meantime, I'm expecting the answers from the participants. Yeah, transmission line modeling is the video link. Yes, yes, Naresh, I have shared that link. Yep, fine. Yeah, Excel sheet link. I think probably you can find it in the description box, or you write a mail to info@powerprojectsindia.com. We will share that Excel sheet. Yes. Yeah, fine. Let's go back and try to find out the answers for the question what we have done here. I'm just not changing anything. I'm just changing the load from 15 megawatt to 12 megawatt. Let me see what's the results. What's the results means what to say. The software assumed this generator 3 as a slack bus or a swing bus or a reference bus, and it is continue to maintain this Gen 4 and Gen 5 as a PV bus. So this Gen 4 and Gen 5 is still generating 5 megawatt. So it is generating 5 plus 5, 10 megawatt. Load is 12 megawatt. So the mismatch has to be compensated by the slack bus. So it generates only 2 megawatt. And the scenario goes worse when your demand further reduces to say example 8 megawatt. Yeah, when the demand is 8 megawatt, I'm not really worried about reactive power. I'm purely worrying about real power. So if you look at means what's when the load goes down to 8 megawatt, when each three generators are running, what we expect each generator to share 8 by 3, that is about 2.7 megawatt. But here you see the results. Both the PV generators, that is in the sense the generators in the PV mode, which generates 5 megawatt each. So the total generation is 10 megawatt. Since the demand is only 8 megawatt, there is a loss of after a small loss means this generator is consuming 2 megawatt. This generator is consuming 2 megawatt. This is not really a real right scenario. This is not really a right scenario. It has to be shared equally. But this is a drawback of a slack bus concept. So whenever there is a demand change, you need to manually adjust the I mean what say you have to divide this 8 and you have to feed it here like 2.7, 2.7, and you have to means what you say adjust the data manually. Then the results will be right, but you need to do that exercise for each and every load change manually. Then almost approximately your results will be okay, right? Still there is a small mismatch because the load is 8 megawatt. I have not exactly divided by this 8 by 3, so I have given I think I have given I think I mean so you can understand what you say. You need to exactly understand means what is the load, and you have to divide equally by all the generators. And this question becomes much complicated when the generators are at different capacities, right? Okay, let me go back to 15 megawatt itself. Let me add another complication. Yeah, none of the questions will be left unanswered. Don't worry, Sasikumar. I'll take up that question. Don't worry. So I'm going back to 5 megawatt. Yes. So now the demand is 5 megawatt, right? 5 megawatt each, 15 megawatt. So it seems like equally sharing. But I'm just doing a small change. Assume this line length, the cable length is not 50 meter. I am taking 100 meters. And I'm taking other line length, the cable length is 150 meters. Let's look at the results what we have seen previously. Previously this 15 megawatt demand is equally shared by all the generators 5 megawatt each. Now I have not changed anything on the generator parameters. I have just changed the cable length between this generator and a switchboard. Look at the results. So there is no change in the real power, but imagine the change in the reactive power. There's a huge reactive power mismatch. That's all because of this cable length. So answer, even if you are able to match the real power, even if you are able to match the real power, you cannot match the reactive power. It means we expect obviously all the generators to share the equal reactive power, but that's not practically possible if you have a different lengths of the cables. And in a reality, obviously means if you have two or three generators to a common switchboard, there will be always a difference in the cable length. So what to do? So I will take up the same simulation in Digsilent Powerfactory, not this week. We will take it in the next week, and we will answer that question. Right? That will be with the yeah. I think Kanagraj is asking possible to post it again. That might be means of that Excel sheet. That Excel sheet, yeah, we will post it. Yeah. Yes. Yeah, you have seen that generators are not sharing that load equally. That's because of the constraint of the slack bus concept, right? Okay. So let me go and look at what is Sasikumar's question. Is it possible to get slack bus voltage and angle if I have the details of three phase and SLG fault current at each slack bus? Answer is no. Sasikumar, your question is, if you know three-phase fault current and single line to ground fault current at slack bus, is it possible to find out an angle? Answer is no. There is no relationship between the short circuit strength and the voltage and phase angle. Voltage and phase angle is more relevant to the load flow, which decides how much power is real and reactive power is flowing. And the short circuit even probably means if you take, like, I have not even given the short circuit current, right? Three phase current and single phase current, I have given it as a 0. So it is immaterial. If you have, even if you know three phase short circuit current and single line to ground fault current, you will not be able to find out the voltage and angle. Okay. So that I believe that is clear, Sasikumar. So I believe this is what the question which you have expected me to answer it. There is a question from Vishal. When a substation receives two sources, I think, yeah, question I have answered, Vishal. If you are receiving the power supply from the same substation via double circuit or two separate transmission lines, you can parallel it. But if you are receiving from two different substations, that is, say, example, if your industry receives a power supply from two different substations, then you cannot really should not parallel it. You should not parallel it. Yeah, droop mode and isochronous mode, I will take it, Parthiban, definitely. But I mean, so to say, that cannot be handled in low flow. We need to do it in transient. So as I told, means we will be flowing with the low flow for first few weeks. Then we will be flowing with the short circuit and motor starting. When it comes to transient stability, we definitely will take this droop and isochronous mode. Okay, with some simulation examples. Yeah, if there's any other questions, there are quite a lot of questions in the last week. I believe I have missed it a few questions. Yeah, can you post the link about the list of power system simulation software? That's a question from Aruna. I think we have answered this question. Means what say, last week itself we have posted the link at the beginning itself, and you can really watch that. Uh, and you can download it. I mean, there is a link which has been shared in the previous week, AskSelva day one. That is on the last Sunday, which we have posted the link. You can take that link, and that's it from my end. If there is no questions, and I have two or three quick updates which I need to give. Uh, yeah, if there is nothing else, I need to give another link for you. Means what to say, we have a program on an interesting topic. We are going to touch three different simulation softwares, ETAP, Digsilent, and means what to say, React. That's going to happen on tomorrow at 11 a.m. in our channel. That is going to be for continuously 3 or 4 days. This is that program, right? So this is a short-term training program on real-time simulation and applications of renewable energy systems. This is the topic. We are going to talk about this topic on means tomorrow. That starts on 13th July to 15th July, 11 a.m. to 12 p.m. That is a 1 hour session. That I think in my view it may go slightly more than an hour, and that means we might be taking about 1.5 hours on a daily basis. That starts tomorrow at 11 a.m. So if you want certificates, probably you can register it. I will share that link. Means this is there in our YouTube channel also, which you can watch. But if you want to, means what to say, really join that session, and if you need a certificates, yes, you can get the certificates by means of having a registering it in your, yes. Yeah, I think my colleagues has posted the link of the softwares again. Thanks for the guys. I think that is to answer question for Aruna. Yeah, believe I have also shared the registration link, which is for the program which we are going to talk about. This we are doing with in association with the Karpaka Vinaga College of Engineering and Technology, which starts at 11 a.m. tomorrow. And the registration link I have shared in the chat box. You can register it and you can attend it. As I told, we are going to talk about modeling and simulation of solar inverter using Digsilent Powerfactory. We are going to talk about modeling and simulation of wind turbine generator using Digsilent Powerfactory. We are also talking about modeling and commercial evaluation of wind and solar using Reactive. So three different softwares you will be able to learn. And means what we are coming up with a course on protection that starts tomorrow. This is exclusively for the industry peoples. I will not recommend this to the academic peoples. If you are an industry peoples, yes, we have a course which we are starting on LV and MV system protection coordination tomorrow. The sessions will be there at Indian time 6 p.m. to 9 p.m. That session is going for about means what to say 12-13 days, and we are finishing it on 25th. That starts on 13th and we are finishing it on um, 25th. And you can see what are the topics which we are covering here. That link also I can share it in the LinkedIn link, which I can share it. You can watch it. We are covering the complete LV and MV protection systems. That means we are covering from the modeling perspective, like modeling of thermal magnetic release, modeling of electronic release, modeling of MCCB, modeling of air circuit breakers, then LV coordinations, and then to an extent means short circuits, modeling a new make model number relay releases. This is going to happen along with the ETAP simulation software. And this I mean so to say we are also covering the medium voltage. We are covering 50 51, that is overcurrent protection, earth fault protection, instantaneous overcurrent, and that's what 51 IDMT overcurrent, 50 instantaneous overcurrent, 51N, 50N. So including 67N for all the equipments we are covering, like transformers, motors, cables, feeders, bus bars, incomers, for a radial system, meshed systems. And in addition to that, little bit we are covering on the CBCT also for sensitive earth fault protections. And we are also covering different topologies and case studies, and we have a session on the CTVT sizing also. And that's sort about the question. For that, probably you have a registration link here, which also you can take it. I can post this. Yeah, someone has already responded, so I'm not able to get that. But the registration link for that program is this. Yeah, I think there is a question from Parthiban. Yes, Parthiban, I will take that question. So I can post that link of LinkedIn post also, so that you can see the course content what we have. And last but not least, for students, we came up with a very interesting program. If you are a student, then I strongly recommend to go with this. Means what? See, we are covering 7 different simulation softwares, 6 different topics, 20 different speakers. We have promised 60 hours, but for sure we will go much beyond this, because this cannot be covered in 60 hours. And means this course starts on means 27th. That's not means per se just 14 days to go. So students have a benefit of means this could be for students and faculties, and even for research scholars and academicians. So this will give you an insight of the softwares like Homer Pro, Homer Grid, React, that is for a microgrid energy storage design, Dialex for lighting design, lighting indoor, outdoor, street lighting, sports lighting, everything. And we are going to cover both Dialex Evo and Dialex. And we are going to cover the renewable grid connected solar and standalone solar plant design, including DC microgrids, preliminary design and project design using PV Syst. We are also going to touch up something, some basics of industrial power system studies using ETAP and Digsilent Powerfactory. So this is for purely peoples, those who are not working in industry, I mean, but they are willing to look at the industry, how it works, and in a long run, if they want to change their career to the industry, this course is there. I will not say this course will convert you, but this is a first step which you can take towards the industry. Yes. And I think that's all from our end. And I believe I can post the link of today feedback form also if you want to have it. I think, as I told, I mean, what say, we will not give the certificates for each and every event of AskSelva, but if you attending at least 5 sessions, then we will give you the certificates that will be available for you. Yes, I have just shared the means Google form to fill the feedback of today's session, and if you have filled the feedback form, you will definitely get the certificates. Yes, that means if you have filled the feedback form for at least 5 weeks, then you will get the certificates. Yes, Venkateshan, Apu, we have shared the feedback forms. Feedback link has been shared. You can take and you can fill it, but don't expect the certificate for one session as we promised in the last class. Also, if you are attending at least 5 sessions, then you will get this certificates. Yes, so continuously follow us in LinkedIn, Facebook, and of course, if you are really interested, join in our Instagram group. Okay, I will also make a post about this Instagram group where we have connected industry professionals. About as of now, about 400 industry professionals are connected in that Instagram group. So you can also ask your doubts and clarifications, which is available. You can post it. Right now, let me take a question of from Parthiban, the last question which I can think I can take it today. Power factor correction is really required in islanded system using capacitor, or we can play with the generator operating mode or generator voltage set point. That's beautiful, very beautiful question, Parthiban. If you have only a what say rotating machines, and I believe your question is more related to the oil and gas industry and with respect to the gas turbine generators or diesel generators. The typical power factor of such a generators are of 0.8. So, including considering the losses in the transformer, etc., if your system power factor is more than 0.8, or if you have over designed your generator capacity, you need not really worry about the capacitor correction. I mean, reactive power compensation or a power factor correction using this capacitors. Your generator itself has the capability to meet the reactive power demand of the loads. If in case the demand, means the reactive power demand from the loads is higher than your generator reactive power capability, then you need to think of capacitor banks. Hope that answered your question, Parthiban. Let me re-stress that answer. If you have a sufficient reactive power capability from the generators to meet the reactive power demand of your system in an islanded mode, you need not really do the reactive power compensation because the generator itself will compensate the reactive power. For that, you need not really do anything. You can just blindly keep this generator in a, so to say, voltage control mode with respect to the voltage. That's more than sufficient. It automatically takes care of whatever maybe the reactive power which is there in the system. But if the reactive power demand in your system is more than the reactive power capability of the generators, then yes, there is no other go. You need to put up the capacitor banks to compensate. But in 99.9 percentage of the cases, okay, Nis, I think. Sorry for that. Yeah, I think we have tried to use the same link. I think we have given an option of only once. So I think I have to change the option, Ahmad Anis. I will change that option so that you can respond it. So give me a time. The link will be available for the whole day. So what to say? I will change the option so that you can fill it. So probably use the same link, and you can fill it probably after half an hour. So immediately after the session, I will correct it. I have given the access only once. That means you have to fill the feedback only once. That's what I have given. Yeah, right. Yeah. I understood, Sasi. Everybody is complaining the same thing. Feedback form link. I believe you have also responded last week. I can understand that. So I have to change an option. I will change it. Give me say 10-15 minutes after the session and try that link. Definitely the link will work. I will disable the option. I'm using basically the same link. So, and hence that's the confusion. So I will allow you to make multiple entries. Yeah. Thank you all. I think that's it from my end. I believe all of you are regular followers of the channel, and you're following us in social media, everything. So thank you, and have a nice Sunday. And once again, thanks a lot for joining us on a Sunday, that too lockdown, and enjoying my sessions. Thank you. We will so to say, meet again probably in the next week sharp 10 we will be discussing more on the load flow, and probably after 3 or 4 load flow cases we will move to the other scenarios like short circuit and other studies. Thank you, have a nice day.